The very earliest cements, dating from as far back as 6000 BC, consisted of little more than slaked lime. When made into a paste with water and sand called lime mortar, it sets over a period of several weeks. The later Roman concrete was superior, based on a mixture of slaked lime and additives such as volcanic ash. By the middle of the 1st century, the material was used to make ambitious forms. After 2 millennia, the concrete dome of the Pantheon in Rome remains the largest unsupported structure in the world. The science of Roman cement was then mostly lost for centuries. Then, in the mid-1700s, British engineer John Smeaton made the first modern concrete by adding ground slag, pebbles and powdered brick to the lime cement. This was used to build the 3rd Eddystone Lighthouse. In the early 1800s, Joseph Aspdin and Isaac Johnson took the next steps by heating a mixture of limestone and clay to well over 1000 degrees. This gave the strong, fast-setting material that we use today. Modern Portland cement was born, named for its similarity to Portland stone, as it was often used to decorate facings on prestigious buildings. The town of Rugby has long been a major centre for cement production. The many smaller cement works were consolidated into one large factory, Rugby Cement. This is now part of the Cemex Group. Today, Cemex need to source their raw materials from quite a distance. The clay comes from their quarry about 11 miles away. Limestone, which is needed in much larger quantities, is quarried 57 miles away. Carrying it this far by road or rail would be very expensive, and the limestone is brought to Rugby by pumping it as a slurry through a very long pipeline. At both sites, Cemex remain conscious of environmental concerns, and worked out parts of the quarries are carefully restored as wildlife habitats. Once at Rugby, the limestone is separated, dried and mixed with the clay. The composition is carefully controlled to ensure consistently optimum properties. It is now time for some chemical magic. The mixture is fired at about 1500 degrees to create several new compounds, which give the cement its ability to set into a strong binding material. Firing is not a fast process, however, and the mixture needs to be agitated and heated for many hours. To do this, it's passed through a very long, slowly rotating tubular kiln, while the chemistry takes place. At the end of the firing, the raw ingredients have now been converted into granular lumps called clinker, a bit like cooled volcanic lava. Cement manufacture is a very energy-intensive process. In the past, heat was provided by burning coal or oil, but environmental concerns prompted a change to alternative fuels. Some come from shredded waste tires, but most of the fuel is now treated domestic refuse, such as waste paper and plastics. Both of these would normally be dumped as landfill, damaging the environment. So using them to make cement has a double benefit: reducing environmental pollution and avoiding the use of fossil fuels. The Cemex plant produces no solid waste, and an elaborate filtration system ensures that virtually nothing is emitted from the flue. Once cool, the clinker is ground in a ball mill. This uses steel balls to crush it to a fine powder. When Portland cement is mixed with water, a whole cascade of chemical reactions take place. The original chemicals are broken down and reform as new materials that set hard. Setting begins after just a few hours, but development of full strength can take several weeks or months. Concrete is a mixture of cement, sand and aggregate, with enough water to make a fluid paste. As anyone who has ever mixed concrete by hand will know, it's hard, back-breaking work. The idea of mixing off-site and transporting to where the concrete was needed started to become popular in the 1920s. By keeping the mix agitated, setting could be delayed by long enough for the journey and give time to pour the concrete into place. Nowadays, ready-mix lorries with their rotating drums are a common sight, taking concrete to building sites and to many other users. It's even possible to pump the wet concrete to the top of a tall building during construction. Concrete is a remarkably cost-effective material and is used in so many ways. In compression, it's extremely strong, making it ideal for pillars and similar uses. It's not so good though when subjected to stretching or bending. Cracks can develop that weaken the structure. Steel, on the other hand, is very strong when stretched, so why not put the two together and get the best out of each? In the 19th century, inventors pioneered the use of iron-reinforced concrete as a building material. English builder William B. Wilkinson used his knowledge of tensile stresses to make reinforced concrete roofs and floors. Steel-reinforced concrete then developed rapidly, making the best of the two materials. It allows easy construction of lightweight, complex shapes. Concrete bonds very well to steel, and they expand similarly when heated. Also, the cement protects the steel from rusting. And most importantly, they share the load bearing in the most effective way possible. Today, cement and concrete are used in a multitude of ways. Modern architecture, with its seemingly impossible designs, roads, bridges such as Birmingham's Spaghetti Junction, and also dams, defence structures, railway sleepers, tunnels, offshore structures, pipes, both for sewage and fresh water, all these along with many others such as lampposts. Cement has come a long way over the millennia and continues to be a vital, if often unappreciated, part of the modern world. Its use grows annually, with enough concrete being made for almost 3 tons for every person in the world.